Hi, this is Mike. In this video, we're going to play around a little bit with a few ideas about connecting Minecraft to Windows Azure. So this all started when I came home from work the other day, and I was sort of spending some time with my little boy who's 9, who's crazy about Minecraft, and he was using this add-on for Minecraft called Computer Craft, and I kind of just sat watching him and realised he was starting to do a bit of coding and stuff, and it was quite interesting watching what he was getting up to. So um, after a while, he asked for a little bit of help, and I started having a look at what it could do. And then suddenly, when I was playing around with it, I noticed it had an HTTP object, and um, so I kind of wanted to explore what we could do with that, and found it was actually pretty cool. So I want to show a little demonstration here um, for this blog post that you've obviously read to come across this article. And the idea is that if we go into Minecraft, we've got a little house here, and if we walk up to our house, and you can see it's got an iron door on it, and it's got a panel to the side of the door. Now, in Minecraft, you can have these things called mods, which are basically add-ons that put new things in the game. And with this particular mod called Computer Craft, if we go into our inventory, so these are all the default things that you get, but you also in here you get this Computer Craft add-on where you can add all sorts of different computers, disk drives, printers. Um, to be honest, I'm not that familiar with exactly everything it does, but it looks like you can kind of build some pretty cool stuff and do some automation within the game. Um, what we're going to do in this video is one of the tutorials on the website um, is about how to kind of build a password protected door. So I'm just going to kind of um, get that up on the screen now just to show people what it's about. So if I just bring this page in here, and you can see this is the wiki for Computer Craft. So if you look at this example here, there's a password protected door where you add your little computer to the side, and then you can write some code that'll run inside the computer. And the idea is that if we take a basic look, you can see you've got a loop, and it clears the terminals, the first line, sets the cursor position, then it asks you to supply a username, sorry, a password, and then what it does after that is it does this redstone dot set output, and that kind of, if you imagine the redstone thing's a bit like sending a trigger for something to happen. So what it'll do is it'll trigger something next to you to do an action, and the idea is that in this case that'll open the door, and then after it's been open for a while we'll close it. And you can see here there's a bit more code showing you a more complex example. So if we go back to the game, I'm going to start this process of creating a new computer. So what I'll do is I'll trash this computer here, and by using the keys on the bottom I can select my new advanced computer and place it next to the door. And the next thing I can do is if I right click on the computer, I can now go in and I get my code editor. Now, if I'm really honest, the code editor is not the best in the world, but it's good enough to play around with. So what we'll do is we'll create a new program called Open Door. And then the first thing I'm going to do is if I use the control button, I'm going to save it. And what's really cool about that is that on your file system, that'll create it'll create a folder over here. So if we have a look as I drag this in, you can see the path here under. I've used the TechNet launcher for Minecraft, which makes it easier for adding mods, which I'd completely recommend because installing them by hand is a nightmare. So the new computer that I've created under this path basically creates a text file for each program you write. So I've got this new one here called Open Door, which at the moment you'll see is as an empty file. So what I'm going to do now is I'm going to paste some code into this file and then just talk through it. So we're going to start off with, and the idea of what I wanted to do before I get too much, sorry, just bear with me a moment while I turn the background on. Okay, so what we want to do then is when I enter the username and password for my Minecraft instance, what I'm going to do is reach through the cloud into the cloud to call Azure API Management, and I'm going to host an API up in the cloud, and then from Minecraft that API call is going to be routed through the Azure Service Bus Relay to go down on premise, and it'll go into a VM that I've got hosted somewhere. On that VM I'm going to host a REST API which will be connected to the Service Bus Relay, and inside that API I'm just going to check against Active Directory to validate the credentials, and then if everything's good I'm going to return back a successful response. And the idea is that you can only get through the door if you can validate your credentials against Active Directory, which, you know, a bit overkill, but it's a bit of fun. So let's see what we can do. So if we have a look at this code, so I've pasted some code into this open door file. I'll talk through this a little bit more in a moment, but basically I'm going to save that for now, and then we're going to run this program again in Minecraft. So if we go in, open our computer, and so just do that bit again just so it's easy for everyone to see. So if I open my computer, and I can go in now after I've saved that text file, and if I edit open door, you can see I've got all the code that was in the text file here to scroll through, and again we'll look at that in a moment. So if I press the control key, and I can exit, and then it takes me back to the main start, so I can basically go open door. The first thing it asks me to do is supply a username, so I'll supply Minecraft, and then my passwords, Minecraft. So now it's opened the door, access granted. See the door's open, and if I'm quick enough I can walk through into the room, and I can walk back out again, and within a few seconds, I think it was 20 seconds it was set to, so after a while that door's going to shut again. There we go. So the next thing to do is we'll run the program again, and we'll supply a bad username, so we'll use not Minecraft, and the password will be anything. And you can see so just to talk through a little bit of this, so what I'm doing here is I've created a JSON response just to make it easy to see. I'm just writing that out to the console so I can see what it is. And then I'm checking access, got a 200 HTTP code back. I got a JSON response which I've parsed, looking for it having true in it, and because it didn't, it's basically access denied, sorry you can't come in. So if we just run it again, there we go, so we can see doors open again, we can go in. So that's pretty cool. So now that's us getting lots of brownie points off kids, so we can do some pretty cool stuff. So let's have a look at what happens under the hood then. So if we just go back into the text editor, and we can see what's going on here then is we start off with our code having the URL for an API management instance, and I've got my key set up there. I've then got an open time, which is going to be how long the door is going to be left open for. The next thing is the side, which when I trigger the computer to push out a signal, it's going to send it to the left because the computer was on the right of the door. So if it sends a signal left, the door will get the action. So the next thing is when we start, terminal.clear and term.set current position. That basically clears the screen, gets us to the top. We then ask for the username, which is these bits here, and we just save it to a variable. We then ask for the password, save that to a variable as well. The next bit is we create an HTTP request, so this is going to be the JSON that we're going to send, so I'm just basically stringing that together using the syntax for the allow programming language, which is what Computercraft seems to use. I'm then going to create some headers, so in this case my call to API management hasn't got any security set on it, but I could quite easily put like an authorization header in here or something, and just note that I've specified the content type. I've got some previous code I was playing around with when I was doing a HTTP get to Google, so just ignore that. But the next bit is I'm going to do a post to my API management URL, passing my headers and my request, and then I'm going to check if the response comes back if it's not null. So one of the things with this is the error handling logic's not that great. So when I was troubleshooting it, I had a couple of issues where that HTTP response just comes back as null, and it was because there was an error and I didn't really know why. So it's kind of tricky to work out with that, so it's worth checking that that's not null. If it's good, then I can get the HTTP response code, and we saw on the console before that was a 200, and then I can do a read line on the response, which gives me that JSON. After that, I've just done a string.match to see if it's got the word true in it, which is, not the best thing in the world, but for our cases it lets us know that was good. I think I did see something about a third-party JSON parser that you might be able to use as another add-in, but for now that's fine. And then all I'm going to do is, if it's allowed, then we'll clear the console, say you're allowed, and then this bit here, this rs.setOutput, this uses the redstone stuff in Minecraft, which is the kind of magic electricity kind of thing that fires signals around that you can do really cool stuff with. So as I say, I'm not an expert in that. Any questions about that, please direct them to my 9-year-old boy. He'll be able to answer them. But key thing is, for the programming side, we set that output to the left, saying it's true, and that'll fire a signal to open the door. We sleep for 20 seconds, and then we fire a signal saying false, which will shut the door again. And if the response was null, it'll originally from the HTTP post, it'll just write to the console and job done. So that's the Minecraft bit. Now let's have a look behind the scenes at what's going on. So if I now go into my virtual machine, and I'm gonna kind of bring this over, I guess. So now I'm in my virtual machine, and just to have a little bit of a look here, so this was using Postman, where I wanted to check my call to the API management REST API I've got. So just specifying the URL, a bit of JSON that I'm going to chuck up at it, set the content type, and we can just check here that works, and we get false when that's not a valid user. So that's good, we know that's working. So let's have a look inside API management now and see what I've done. So the first thing I did was to specify an authentication URL, and you can see here I've got my Acme Services Management, and we've got this authentication API. Within that, so I've created an operation called login, and I've basically set a rewrite on it, and put some documentation in there, specified what the body is and stuff like that, and that's kind of pretty cool. So we're looking pretty good there. The settings for it, so if we just jump down here, so you can see I've declared a name for my API. I've set the connection type to be direct, which means I can call onto a sort of public API, and I've specified the URL for my Azure Service Bus namespace. I've given it the authentication suffix for the public URL I'm going to publish, and then I've set allowing it to be HTTP and HTTPS. And basically what that's going to do is it's going to get the call comes in, and it's going to forward it on to Azure Service Bus. The next bit is the policies. So I've gone in and I've set up a policy for this API, and you can see here, if I go and just edit that so it's easy to see, So I've done a rewrite on the URI, which specifies what the URI for the end REST service is, and then I've also used this service bus authorization header. So I got a little bit of help off Santosh earlier just to confirm how to do this, and basically what I'm going to do is if I specify that HTTP header, I can add a token here in the policy, and that'll flow through and it'll validate against the SAS token required to access the service bus relay namespace, the relay endpoint. And that'll mean that I've got that endpoint locked down so only API management can call it. Now, I think probably need to do a little bit of thinking about that token and the expiry and the best way to manage that. But for now, for the demo, that'll just work. And that's kind of it really. So I've also noted I've got the conversion to JSON on the response, and everything's kind of pretty simple in the policy. And if I go into the service bus namespaces here, and I go into my Acme services one, and you can see there's nothing particularly fancy with this other than that we've got a relay that's set up. And listen, we've got this login service, and I've got a couple of SAS policies set up to just to allow this to all do its magic. Now, what I've got after that is I've got my console application here that does the magic behind the scenes when I'm doing the logging in. So what I'll do just to demonstrate that is I'll kick that off again. So we just start that up. See, that's all up and running fine. So the next thing I'll do is I'll just jump back into Postman, and I'll just double check this is all working okay from a yeah, that's working fine. So now I'll jump into Minecraft and I'll just do a quick check. So in the console app here, we should have seen we've got already one request saying AJ is not allowed in. If we go back to the game, and hopefully I can get out of the door. So we'll have to open it from the inside. So run our program and specify our username. Then the door's opened again and we can go out. So if we jump back to the console, you can see here we've just had another message saying service was called by Minecraft is allowed in. So you can see that proved that Minecraft called right through the API management, through the relay, into our code, and then we returned that back. So now let's have a look at what the code itself does. So if we stop the console app, and if we have a look at Visual Studio here, and I'll kind of show you the pretty, there's nothing really too fancy with this code really. So I've defined a WCF REST service here, and I've got my login service. I've got the web invoke on this method called authenticate. I had a couple of other operations just to help troubleshooting, but I'm not too bothered about those. We'll do a post, and we've got this login request which will return a bool value. And if we have a look in the service implementation, so what we're going to do is it'll come in, I'm going to look up the domain name from the config file, and then I'm going to create a principal context, and I'm going to use this validate credentials operation that lets me supply a username and a password, and it'll tell me whether they're valid or not, and then I can just write out to the console what happened like you saw before and then return that value. And then in the config file, I've got some code here which will specify this is a WCF REST service. We'll use the web HTTP relay binding, so it'll open up a connection on the service bus relay, and we've specified our endpoint here. Originally I had it running with no security, so we had this bit in, but I've turned that off, so it requires the caller to the relay to have to supply a token to access it. And then I've got just a little bit of stuff here about, so here's the transport security setup for me to listen on that relay instance. The rest of it's pretty vanilla WCF and service bus stuff here in the config file. There's nothing fancy, so you can see, although that was quite a complicated scenario to be able to go from Minecraft through API, through Relay, on-premise, to a VM and do a call against Active Directory to validate it, and then right back round. It actually wasn't really too difficult to do, and certainly on the server side, the code wasn't really that much code to actually make that cool scenario work. So hopefully that gives you a few ideas about how we can build some APIs that makes it easy for us to play around with having some fun in Minecraft and do some cool stuff now. Cheers.